Great. Now, anybody else who is stuck? So yeah. All right. All right. A question from Ali is that is there a compatibility issue because I was not able to log in from Firefox but worked fine with Chrome? Yes, sometimes that becomes an issue. Yeah. Okay. Great. All right. All right. Great. Great to have great to have everyone except Arun to log in. Arun will also be able to log in very soon. Okay. Okay. So all right. So this is the My Lab tab where you get lab credentials. These are the main services. Ambari is the service in which you see all the controls. Like if you go into, these are the various components of Hadoop ecosystem that we will be using. But for now, just to give you an overview that yes, there are so many machines. I'll just show you some of the machines. Okay. Let's say if you click on hosts, there are these many machines. And let us say in the cluster, you want to add more machines or remove some machines, you can simply select and click on add new host. Okay, so this is how the installation happen. So what we do usually is um, okay. All right. What we do is on one of the computers, in our case, it's a.cloudxlab. It's a.cloudxlab. This is B, C, D, E, F, G. On A, we have installed Ambari, and then we added the host to it, and Ambari went ahead and installed on all the machines. Okay. So everything that we are going to learn in this session is about okay. Whatever we are going to learn in this session is about something that can run on many machines. The idea of big data is all about distributed computing. Distributed means multiple machines working together for a single objective. Okay, so a question from Manoj is, do new machines have to have same specs as existing machines? Yes. So basically, the hardware wise, no, but operating system wise, yes. Okay, what does it mean? It means that in a cluster, there can be multiple machines with different specification. Do you see that? There is one machine which is 7 GB. There are these machines which are 16 GB and so on. All right. So the specifications might change. Like memory could be different, disk could be different, but the processor and the operating system both have to be identical for the Hadoop cluster, although this should not be the requirement, but for some reason in Hadoop, this is the requirement. Okay, there is no clear justification for this, but when we try to install Ambari with disparate, as in different kind of hosts having different operating system, it gave an error saying that all of the hosts should have same operating system as well as the processor and architecture. Okay, while the memory and the disk could be different. Or even the processor size, like it could be 1 GHz in another it could be 2 GHz. Okay, so that's Ambari. And next is Hue. Hue means this is where we will be interacting with Hadoop ecosystem. Okay, so Hue is a web interface to interact with the Hadoop ecosystem. And the way we deal with Hue is we click on this and it should open login window for you, and there you can provide login and password, this login and password. Okay, prefer to copy paste instead of typing, but some browsers do not allow you to copy paste, and there you might have to show password and then type it out. Okay, so in those cases you might have to type it, otherwise copy paste should work. Okay, so please log in into Hue as well. Okay, what is Hue? Hue is a web interface instead of using commands to talk to Hadoop and other services. Hue provides a web-based interface which is friendly if we want to talk to various components in Hadoop ecosystem. So when I click on file browser, it takes me to this kind of folder structure, which is HDFS. We'll talk about these things in more detail. This is one component of Hadoop, which is a file system like your Windows file browser or Finder in case of your Mac. Okay, now here what you see is using this editor, we will be using Hive. Using this, we can use Pig, and we can use the job designer to interact with OZ. These components, I can go over them again briefly, which we discussed in the first session. All right, but let's just first try to log in, and then we will will attempt these components again. Okay, so getting started is something very important. Okay, and in every learning what happens is it can never be a single flow. So some things right now we would go over back and forth. So do not worry, everything is in the right direction. Yes, Vinny, you want me to unmute?
Yeah,
Oh,
yeah. Could you please help me to log in because I tried. It's not. I don't know.
okay.
Shall I share my screen?
Yes. I'll just stop sharing so that you can. Okay, Vinny, go ahead.
Are you able to see?
And not yet.
I think I share the screen.
Maybe some pop-up is there which is asking you to select which screen do you want to share.
Oh, okay.
Okay. Yep. So yeah, now you're able to log in and click on My Lab, right? Go to lab credentials. Okay. Let's click on Ambari. Ambari, yeah. Okay. I get it. I get it. So in the IE, probably there could be an issue.
Oh, okay.
We can log in both parallelly. No worries, Ali, Ambari or Hugh. Did it open? No, right? I see. I see. It's going on, but try Chrome if you have Chrome. Okay, we can't see Chrome because you have only shared the IE.
Oh, okay.
Okay, so I think it's a browser problem. These, yeah, the Ambari is from a company called Hortonworks, and the Hue is from Cloudera. So there are two major vendors of Hadoop. One is Cloudera, and other is Hortonworks. Even though Hadoop is open source, but there are companies which contribute to Hadoop majorly and who has invented a couple of tools. And those two companies are mainly Hortonworks and Cloudera. So these are the components designed by Ambari is from Hortonworks and Cloudera has created Hue. So we are using both. So Ambari, they may not have made it compatible with the IE. So can you try with Chrome? Oh, for Arun, it actually worked in Chrome. You have Chrome on this machine? Okay. Are you around? Can you share? I'm going to, okay. So can you share your screen, Finny? Oh, Finny's connection has gone down probably. Can you hear me? Okay. All right. Good, good. So Finny, can you try with Chrome and then let's give it a shot? Okay. These teething problems happen only in the beginning. Once these are resolved, you will not have any other issue. Okay. And why I want you, all of you, to try now is because this way you will not have a mental block of doing hands-on while we are hands-on together with me. Okay, so to avoid the mental block that it's too hard to do hands-on, we should log in now. It's just the beginning. The first baby steps are the only hardest thing in order to learn anything. Rest becomes very smooth. All right. So Finny, are you trying with Chrome?
Actually, I don't have Chrome in my machine. It's Firefox, and
Okay. Okay.
so I'll download and
Try Firefox. Maybe that works.
no, my
Okay.
Firefox was not working. That's why I was trying
Oh,
to get.
okay. Okay. Try with Chrome. I'm sure it'll
Yeah,
be able to work. Okay.
okay, yeah,
All right. Great.
thanks.
Thank you. Thank you. Otherwise, we'll try offline. You just ping me in case the Chrome one is not working. One of us will try to get you up and running. This is very important. As in, by the second session, everybody should be able to log in and get started with things. And because I mean, I've conducted proper studies whereby I taught people for 2 weeks and then I asked them questions. The only parts that they remembered were where they had done hands-on or they had asked questions. No matter how attentive they were in listening to what I was saying, but only parts that most of the students retain is where either they do hands-on with me or they they ask questions. So only those parts you're going to retain. All right. Not how great I speak, but what you do. All right. Next thing we are going to give it a try is web console. Click on the web console and we log in. I have copy pasted my login from here. Okay. I've copy pasted my login and then I'm going to copy paste my password. Where did it go? Here. All right. Are you able to log in? This is a little tricky part. It takes a little bit more time. Okay. So we are logging into console. Click on the web console, and this is where you log in. It's a proper Unix environment where you can run any Unix command, and from a Unix command you can actually achieve anything. You can interact with any component. Okay, therefore it's important for all of us to learn Linux or Unix. And for that, what we have done is we have made it extremely simple. We have made it extremely simple. I will show you. If you go after logging in, if you go into, say, I'm trying to log in again. I had logged out earlier. Okay, so the fourth chapter is about Linux. It teaches you how to work with this console. Okay, and if you want to be data engineer or data scientist, or you in any kind of domain if you want to excel in computing, Linux is kind of the most important skill to have. It's kind of the base of most of the learnings that we have. And as per my understanding, most of the people who learned Linux, their careers actually have gone really well. Okay, so I'm into the industry for more than 15 years, and what I found is that most of the people who were good at Linux are more successful comparatively. Okay, I'm not an ambassador of Linux or anybody. Linux is an open source system, but this is just one observation I saw in case of the success curves of people in IT industry. Okay, good. A question from Yogurani is, the session is enabled in Ambari? Yes, it is. Okay, Ambari, it's not Ambani, it's Ambari. I have a little cold, so it might sound like Ambani. And okay, so yes. Now, so finish these 87 pages by the next, this weekend, as in during the weekdays. It's not too hard. You can very quickly finish it. These are like mostly hands-on sessions. It'll be very important for you to learn. And half of the data science is about this. Okay, half of the data science you'll figure out that can be done with the Linux without having to do anything with Hadoop or anything. Okay, so it's very important skill to gain, and that's why I'm emphasizing again. Okay, now coming back to where I was. So in the my lab, we talked about Ambari, we talked about you. We were trying to log in as console. Okay, so please raise your hand if you are able to log in. Oh, nobody is able to log in console. Bhuvan is able to log in. Shivani, Rex, good. All right. If you're stuck, I would like to take a look. Okay. So Arun is able to log in. Or you need help? Okay. Okay. All right. So Bhuvan, Rex, Shivani, George, and Ali. All right. For others, you need help. You want me to take a look at your screen, and that way we can solve everyone's problem. This is the first session, so we would like to get very comfortable. Okay, great. And Yugrani is also able to log in. Great. Tanmay, you want me to take a look at your screen? Should I stop sharing? Arun is able to log in. Great, great. All right, great. So Tanmay, I'm guessing that raising the hand means that you are able to log in. Okay, Finny, are you able to, by any chance, when you open Web Console, is it opening in IE?
It's not opening.
Same thing is happening.
Yeah, same thing.
Let me
I,
again.
I'll try offline. Yeah.
Okay, okay. Do you want me to once more take a look so that I can observe what's happening? Yeah, I've stopped sharing and you can share your screen. I'll just take
Actually, I
a.
was downloading the Chrome and try actually.
Oh, okay, okay,
Okay,
okay,
but I can share. No problem. One second.
okay. I'll just take a look and then see if we can do something. Okay.
Okay.
Mohammed, please keep an eye. Okay. So Shahrukh is from my team and he's also a good engineer. And yeah. All right. Please. Yeah. You can share your screen and I can just take a quick look. If anybody else is stuck, let me know. All right. All right. Oh, like this. Okay. Okay. It is kind of stuck exactly there. I see. I see. I see.
Yeah, yeah,
Okay.
it's kind of stuck there.
Okay, now Ambari has come. This UI.
Oh, yeah, right. Yeah, okay.
Looks like
So
there's some kind of plugin which is stopping you. Don't copy it like this, just copy paste. That'll be easier because when you copy like
oh,
this,
this one.
just yeah. Now try. Is it okay? Similar thing. Let's do for the paste. Yeah. Okay. Finally, you're able to log in Ambari. Can I take a look at the console also? From my lab section. Yeah. Click on Web Console. Is it going blank? There is something wrong because it looks like there's some antivirus or something which is kind of taking too much time to
Oh,
let through this control.
oh, okay. Yeah, I'll check that.
Yeah, yeah. I think it'll come. It might come in a while, but it should come. Okay,
Okay.
wonderful, great, and all right, great. You are able to log in Ambari. Okay. All right. Great. Great. So yes, so all of us are able to log in, and this console that you see here is a nice thing because from here you can do anything you want. Whether you want to work with Python, you can easily launch Python from here. You want to work with Scala, you can work with Scala. You want to interact with Hadoop, you can interact with Hadoop. If you want to interact with Hive, you can interact with Hive. All of the components that we will learn, you can interact with all of those from here, as well as you can use the standard Unix utilities to do the data cleaning, data churning. If you want to work with R, you can just type R and start working. Okay. And another most important powerful tool that we have installed is it is called Jupyter. Okay. So I'm just going to give you a quick demo of Jupyter. These are just beginning of the things, right? I'll tell you what is Jupyter later, but what we learned is if we give a playground first and then talk about something, then it makes more sense. Okay, so Jupyter is a nice web interface which lets you work in the browser instead of console. I know that many people are not very comfortable with the black screen, this console. Therefore, we installed Jupyter for you. Jupyter is a web interface to do most of the work from the browser. Browser as in a more friendly UI. Okay, so I'm going to we just started Jupyter. You can just type Jupyter and press tab. It should auto-complete to Jupyter Spark. We will be using Jupyter Spark later, but for now, this is good enough. Now, it has given us this URL. You can copy everything from here till the end, and also notice with your console address. Your console address could be different from mine. Mine is e.cloudxlab. Yours could be F or G. Okay. So for me, it's E, and you can note what is for you. All right. So let's copy this. I'm copying this URL. Okay. And paste it in the browser window. Okay. Now it won't work. Why? Because 0 means localhost. All right. So what you have to do is whatever is your console's address, that's the IP, that's the domain name you have to put in here. Okay. So yes, when you do that, you'll able to see the folder structure. Okay. So this folder structure inside Hue is of Hadoop file system, while this one is your local file system. Or not this one. This one is the local file system. Okay. So Jupyter is a nice web interface to interact with your Unix file system or Linux file system, as well as you can work with, say, R, Python, Scala from here. Say I want to work with Python. So all I'll do is I'll just select this one and start Python here. Okay, so it will start something called a notebook. This is a notebook in which we can write our program. Let's say I'm saying x equal to 10, and to execute something we can say shift and enter. Okay, shift and enter. Now if I say x plus 4, the answer should be right. And all right, those who are asking about the command that I executed for Spark is this. Okay, so to execute what I do, I press shift enter. All right, now probably I'm hoping that everybody is able to log in into console. So are you able to start Jupyter this? So what we learned so far is how to log in into Ambari, how to log in into Hue, how to log in into Web Console, then how to log in into Jupyter. Okay, to log in into Jupyter, we have not started Jupyter by default. We are working on making it as seamless as logging into Ambari and everywhere. We plan to run Jupyter for everyone. But for now, we can start Jupyter this way. How can you exit Web Console? That's a question from Ali. You can either just close the tab or press Control D. Control D is something that you can press. The Scala one, again, most of the command prompts can be exited using Control D. Okay, press Control and press D. All right, Shell, Python, Scala, everything can be exited by Control D. Control D in Unix means end of the input. Okay. Yes, so you are able to start Jupyter. And are you, so the procedure is make a mental note of e.cloudxlab, where it could be, for you, it could be F, for some, it could be G.cloudxlab or F.cloudxlab. For me, it is E. Why it is so? Because there are many users of CloudXlab, so we want to distribute them amongst multiple machines. Okay, so some of us are logging into e.cloudxlab. Logging in means you are there. You are on e.cloudxlab.com. You are actually doing things on this server. Okay. Now, what is Jupyter? Jupyter is a general tool. Jupyter is a general tool. The way from console you can interact with everything. Using Jupyter, you can interact with file system. Let's say you want to upload something in this file, right? This is a computer. e.cloudxlab is a computer, and it has given you a home directory. This is my home directory in which you can upload file down and keep the file there for as long as you have access to this account. You will be able to maintain your data there, right? Now, if you want to interact with uploading file, downloading file, you want to interact with Python from a more user-friendly interface, then Jupyter makes it very, very easy. All right. So 0.0.0 is a loopback address for your local host. So you need to replace this with e.cloudxlab.com is the host name of e.cloudxlab.com. All right. So this needs to be replaced with e.cloudxlab, f.cloudxlab, or g. Whatever you see here in the browser. It's little tricky right now. Okay, so I'll show you again. I'll take this whole URL that's printed after I run Jupyter Spark. Okay, if I give you my URL, you'll be able to log in into my session. Okay, but I don't want that to happen. You should have your separate session. Okay, so here I'm saying e.cloudxlab.com. All right, so instead of E, you could have F or something else. Okay, so since this is a home directory, this is your home here. When you are here, this is a home directory. Here Here, either you use Linux command to manipulate files, or you can use Jupyter to interact with that. Wonderful. So great. Shivani and Tanmoy are able to open Jupyter. Okay. So we can you interact with Python, or let's say you want to plot, let's say you are an analyst and you would like to plot graphs in R. Okay, so you can just plot graphs in R, or let's say, I'll just show you, let's say you are working in Python and you would like to draw graphs and you would like to do all kinds of processing, you can do it here. Yes, Manoj, I'll just show you. Let's say plot graphs using Python. Okay, I'll just show you a simple example of plotting graph here. So if I just use this code, all right, you can press Shift Enter. Not this one. I'll just show you something else. There is another one which is, let me just see if I can get something else. So matplot is not working correctly. Okay, let me go back here. Let me see if I can do quickly. Am I in Python? No, I think I'm in Scala. No, this is Python only. Okay, let me try again with some other library. There are nice ways to do that. Let me see if I can do something. If this works. Matplot generally works here. Import matplot. Okay, no worries, I can show you later. Right. But yeah, the difference is even though you can do everything from here, from the the console, but you would not get the graph and other things as in a so simple interface. Okay. Also, uploading, downloading file is not possible from console. Okay. Therefore, we have put Jupyter so that you can interact really nicely. Okay. So let me say, for example, you want to upload a file here, you can upload. Okay, question from Arun is, I'm not able to see any file system structure in Hue for Hadoop. That's right, because you don't have a file right now. Okay, it'll be completely empty for you. You'll only see dot and maybe dot trash. That's all. Okay, so you can just check with uploading if you want. Similarly, this will be empty for you. Okay, the normal local file system will be also empty for you. Okay, so let's just try to log in and we'll learn these components as we go. All right, question from George is, which is better in your opinion, R, Scala or Python? Because I've read several blogs discussing this. We will discuss this and we will focus on the course. All right, I'd like to discuss it a little later while we discuss about Scala. All right. But in my opinion, learning Python is inevitable. And if we are going with Spark, it's important to learn Scala. Good news is Scala and Python are very similar looking, so you will not have much problem shifting between the two. And with respect to R, there are humongous libraries available in R. So you can use those libraries in Python's pandas. There is a library of Python's panda. which is very similar to R. Therefore, most of the data scientists, data engineers end up using Python instead of R. Okay, Scala is used with Spark mostly and is high in demand when it comes to Spark. Therefore, we are taking up Scala, and Python you will learn. Okay, no worries. So we'll go into more details later. Does the URL of Jupyter change for every session? Yes. Okay. A question from Manoj is how did log into prompt, as in console, right? Uh, so you mean when you click on web console, then this will open and there you provide your login and password. All right. Yes. Okay, Finny, you want to say something? You're unmuted. Okay.
Yeah, yeah. I
All right.
just able to get the console.
Okay. Okay. Show me your screen, please. All right. In the meantime, Manoj, are you able to figure out? Let me take a look at it. How did you log into prompt? Okay. So using my console. All right. After that, I'll take a look at your screen if you're stuck. A question from Tanmay. Pandas, NumPy, scikit-learn, all part of Anaconda installed? Yes. So all of these libraries that are needed for machine learning or data sciences or data analytics, we have installed all of those for our users. Okay. So even though you are attending Hadoop Spark course, but you are open to use all the machine learning and deep learning infrastructure. All right. There is no restriction to it. A question from okay. Yes. Now let's run. Okay, great. So you're able to log in into Ambari, Hue, and console. Wonderful, wonderful.
Yeah. How do I
Now
connect to Jupyter now?
Jupyter, just type Jupyter, Jupy, okay, and press tab. Press tab, it'll autocomplete. No, yeah. Jupyter dash. Now say Jupyter dash, and then press tab again. You can use the arrow key. Yeah, again dash, and then press tab again. It's not completing. Yeah, Jupyter, you can just say S, Jupyter, S, and okay. So basically it's giving suggestions, right? Jupyter, nah,
Jupyter S.
Jupyter dash S, and then it'll complete to the whole thing. Yeah, enter, not enter as in press tab, sorry. Okay. Or you can just type the whole thing. It's up to you. Yeah, go ahead. So you can use tab cleverly in order to autocomplete most of the commands.
So
If it,
now enter.
yeah, enter. Yeah, let it be. Let it be. It's starting up. So you can see this URL, log in with this token, right?
Oh,
And
yeah.
one is that you copy this one,
Okay.
Yeah, good. Now, right? And your console is at g.cloudxlab, right? Paste it here. Paste it here.
G dot cloud X11.
I think so. Yes. Yes.
Yeah.
Right. G.cloudxlab. Now paste it here and go back to the beginning. Yes. Here instead of 000, after double, yeah. Let this port be as such. Let this port be as such. Let this port be as such. Again, paste again. Yeah.
What do you need to do?
Uh,
G dot
Control J.
cloud X labs, right?
Yeah, but you also deleted the port number. Okay.
Oh, okay.
So basically, in place of 0.0.0, we have to say g.cloudxlab, right?
Oh, okay.
Zero, yeah. Zero means like when we say I, right? That's zero.
G.
Okay. And if you want to call, instead of I, you want to call Sandeep, then you have to give the host name. Okay.
Products lab. It's HTTPS.
That's okay. That's okay.
So now fine.
Enter. Yeah. I'm hoping that it should work.
It takes little time at the first time.
It generally does not take that much, but it will open. Okay. And
Yeah, then, yeah, you can continue then.
all right. So after that, you can interact with Python, Scala, and these components. I hope everybody is comfortable so far. And all right.
So this is Jupyter. Okay.
Yes. All right. Can you share the screen again? I'll just walk you through a few things. Yeah.
Okay.
Yeah, that's okay. I can see. I can see.
You can
All
see.
right. Yeah. So here, if you want to upload something, you can click on upload, and then you can upload your data into the console.
Uh,
And if you want to, let's say, open Python, then click on
okay.
new, and then you can click on, say, Python conda root, Python conda. Yes, that's the one. What happened here?
That's opening, I guess.
Okay, it's opening, I guess.
Oh, similarly, you can do Scala also, right?
Yeah, that's a Scala.
It's another window will open there.
Yes, and then R. I think open. It'll take some time.
Okay.
I think some this it is, you know, opening. You can see that.
Okay. Yeah, I think. Yeah. So.
All right, great, great. All right. So yes, it's only the first day that you will feel a little out of place with the new tools, but soon enough you will be comfortable. All right. So Yogurani, you can share your screen.
So should I
Uh,
stop sharing or?
yes, please. Yes. Okay, great. Yes, copy this, and your host is e.cloudxlab, right? Host name is e.cloudxlab, right? Just paste it in another tab. Yes, paste it here, paste it here. Now change 000 to your host name. Replace, instead of all those 4 zeros and dots. Yeah, delete this. Replace this with e.cloudxlab.com. Right? Why E? Because E is your host name. There is extra E before X. Before X, there is an extra E, and there is a typing mistake. Yes, press enter. Great. So it is opening the file system, right? All right. You can click on new. You can click on new and say Python conda root. Python conda root. Yeah, that's the one. And say, let it open. Say 2 plus 3, 2 plus 3, and shift enter. All right. So this is your first Python program you have just written. All right. Great. All right. So this way you can interact with most of it, and we will learn a lot about these tools as we go ahead. Okay. Great. All right. So I hope you are not finding it too slow, and this is an important part of the exercise, and that's why. Okay. So we talked about a couple of things, and yes. Great. Now, here what you see is we are able to, these are various services provided by the lab. There is Ambari, there is Hue, there's a web console, and there is Jupyter. Jupyter is something which we started after logging in into web console. All right. So again, if you go into my courses, you will be able to see one recorded course. This is a recorded with all the exercises. All the exercises are in this course. And another one is this one. This is where we will upload your recordings. Okay, you will be able to see all the recordings of the course here inside it. Okay, so in the session one, these are the two getting started with big data webinars which we conducted so far. And for this session, you can take a look at these. All right, because some of you who joined today wanted to attend this one, so we gave an extra webinar. All right, so so you should go over this one. All right, so we are able to log in into CloudX Lab, all of us. We are able to log in into the website. We are able to see our courses. And okay, now this is great. Now I'll just go over what we have discussed in the first session quickly, and then we can start with our other exercise. All right, so all right, so this is something we're talking about assessments. Assessments are something that you must take a look. Why? Because if you go here in my courses and you go into this particular course, at this point, it will ask you to do things with it. Okay, say you are logging in here, there'll be some objective questions, and then it'll ask you to log in. It should be you have successfully logged in. Okay, can you try? If you are able to get the great, you have successfully logged in. That means it has worked. Okay, so it's actually checking whether you are able to log in into console or not. All right, and then as you go ahead, there will be many exercises like how to create file, create directory, and so on. So here it will ask you to create a directory in the console, and it will let you go only if you have created this directory. Since I had already created this XYZ directory, that's why it has worked for me. Okay, so you must give it a try. Trust me, it's going to make you learn something which takes a very long time in general. All right, so because it's like fundamental part in Linux, therefore it's important to learn this part. Great. So that's about automated assessments. Are you giving it a try? If you go to my courses, Arun, you have a question, you have raised your hand, and Finny. No questions? All right. Okay. Okay, then I'll lower the hand. Great. So far, we have been able to log in into various services, and this is very important. This is important not because of only this particular course, but also if you are planning to learn any other things in the data science or machine learning or data engineering or any other language, this lab would help you, because I've never seen a, a data environment or server environment which is not Linux. Okay, Linux or Unix. I've worked on Solaris, I've worked on HP Unix, I've worked on Linux and Mac. So I found that mostly this knowledge of Linux will be very important to you. Okay. as well as the whole environment is going to help you learn, whether you're in office, at home, or anywhere. Great. So, so this assessment is going to help you get started, and this is okay. All right. Now, we talked about data variety in the first session. Data variety as in structured, unstructured data. In structured data is generally tabular, where we have clear a clear idea about the folder, about the column data types. Okay, so SQL is structured, while plain text files are unstructured, and CSV files are semi-structured. Okay, so when we say structured, we are generally referring to data relational databases. Okay, distributed systems, getting something done using multiple computers, is distributed computing. And but such systems which can do distributed computing are called distributed system. Okay, I'm going to skip a lot of things. So this is the definition that we are going to stay with. The definition is a problem that requires distributed architecture is called big data problem. The data that needs to be that for handling of the data, if you require distributed system, it is big data. So big data, data of very huge size that requires distributed computing. What is distributed computing? Is using multiple computers to get work done. That's why in Ambari we have so many hosts. Okay, that's why in Ambari we have so many hosts, and that's the reason why we use Hadoop, Spark, or any of the tools in this session, this course. All right, the course is going to be at least 18 3-hour session. So 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 do more hands-on so that you don't get bored. All right, this is the only theory part. Now, the basic characteristics of big data is volume, velocity, variety. We all know these parts, that data has volume. I mean, we need to store data, and to process, we need to have good machines which can process data, and which is coming fast from the users. And then there variety, as in there are variety of problems and variety of data. Okay, so variety of problems can be, variety of data could be in the form of maps or something like that. All right. So here what we talk about is a very important aspect, that it takes a long time to read data from the disk. And therefore, handling humongous data, if the data is really big, is not a function of processor. It's a function of the disk read speed in many cases. All right. And the data is important because the devices have become omnipresent and very powerful and faster and smaller. Okay. And the connectivity has also improved. Therefore, while devices generate data, via connectivity, the data get transmitted from one place to another or multiplied using the social networks and other means. So these are the four components of the computer that we generally talk about: CPU, RAM, CPU as in the processor, Intel, the Pentium, or say AMD, AMD, or Qualcomm. And there is RAM. There basically the what matters in case of RAM is how big is RAM and how at what rate we can read. RAM is nothing but a huge array of a huge array of you can say switches, in which we can address each switch directly. That's RAM. We can jump to any switch very quickly. Switch means it has a state, on or off. Okay, so using processor, we turn on off these switches called RAM, and these switches stay. This whole configuration of switches is basically called memory, and that's the RAM, random access memory. Okay, and the RAM retains the state as long as there is electricity in the computer. Therefore, we need to persist data keep in the disk. Disk is important. There are two kinds of disks, hard disk and solid state. Hard disk is cheaper and bigger, while solid state is faster and costlier. Okay, but and smaller. Then, so hard disk is traditionally used in the laptops and the desktops, while solid state is the new time, which is generally used in iPads and MacBook Airs and so on. Okay, and the network is something very important too to do the processing, because if your data is not fitting in the RAM, you will put it to the disk. If one disk is not sufficient, we'll put it another computer nearby. Okay, so and these can become the bottlenecks. So examples of big data customers are recommendations, and recommendations can be done using MLlib, which we will be talking about during one of the sessions in future. And A/B testing, as in testing which configuration works well by kind of experimenting with users' behavior. So we, like the way we test drugs, we similarly we also test features. In this, more the data, better will be the results, and therefore A/B testing is a good use case for humongous data. And government, telecom, healthcare and others are very finding handling of humongous data very useful, and are able to solve their problem of huge data using the current solutions. Current solutions that there are quite a few solutions to handle humongous data, handle huge data, and one of the most popular one, and the one that gives us the complete control, is Hadoop with Spark. Okay, so Hadoop was created based by Dockering, and it's based on Google File System. It's a suite of components. It's a suite of components which all of those are distributed, scalable, and reliable. It is started with three components. One is file system, a and database and um, MapReduce, the computing engine, and then it became. Let me spend more time on this diagram. All right. So, Hadoop distributed file system is the most important component of Hadoop ecosystem. Okay. Hadoop distributed file system is a place where we keep the data in the file. All right. Now, since we have already done hands-on, I will just tell you where is Hadoop distributed file system. Okay, don't look at my notes here. And all right, so I'll just show you. Okay, so let me just log in into my lab and go to lab credentials. We're going to make it a little more easier later. Okay, so when you click on file browser, this is the file system. Okay, it's not same file system as your host here on inside the console. This also has a file system, the one that you saw inside Jupyter. This is not same as this. This is the HDFS. Inside Hue, the file system that you see is HDFS. Okay, this one can store humongous data, and all of this file folders and everything is using multiple machines. So some of these files could be on A, some of this could be on B, some of it could be on C and D. We will understand the more details about how this distribution of files and folders is happening over multiple machines. Okay, so for now, the important part to understand is the Hadoop distributed file system can store humongous files. Okay, Why? Because it runs on top of multiple machines, meaning to give you this huge file structure right now in case of CloudX Lab, 8 hosts, 8 computers hard disk is combined into single one. That's how you can visualize it. Okay, so more and more computers you keep on adding, the storage keeps on becoming bigger and bigger. And that's where the Hadoop distributed file system plays a big role. It is based on Google's file system, and when Google started, they could not afford really highly costly hardware. Then what they did was they built this kind of a file system. Okay, I heard my echo. So they built this kind of file system which could utilize many hard disks and many computers. And what Google's founders did was that they bought older hard disks and older computers from people in their in their university. And that's where they were able to store humongous data from the internet to make the search engine. All right. So that's what is the Hadoop distributed file system about. Now, since the data is on multiple computers and you would like to process the data then and there, and that's where Yarn comes into play. Yarn is like a operating system to which you give the program and it can execute where you want in the network. Okay, you want it to run on A, B, C, D, E, F, cloud.cloudxlab or g.cloudxlab. Yarn can do that for you. So Yarn is kind of your one-stop um, resource manager, whereby you can just ask it to do things on the cluster and it will do things on the cluster. Okay, cluster means multiple computers connected together. Okay, so Yarn will do the running of program for you. But since running of programs is little more involving, Tanmay, you have a question. You have raised a hand. Yes.
Yeah, so can you hear me now?
Yeah, I can hear you. You can also ask a question using typing. Yeah.
Right, right. Yeah, I
Yeah.
generally do that, but
Okay.
like might be a little bit involved, like maybe interactive little bit. So my question is like most of the requirement today involves like they ask for along with these technologies are fine, but they ask for Amazon AWS or Microsoft Azure,
Okay.
those kind of combination along with the big data, right? To whatever we are learning here.
Right.
Thing is like we are not getting exposure to that piece of the puzzle, right? So how do we translate or how do you fill up that part, like because it looks like everything kind of everything is ready for us to use, like more of a like Hortonworks or clouded stuff as if we have downloaded it my own machine and practicing. That kind of
Okay.
environment is set up. But we are not really getting exposure to the other piece of the puzzle like Amazon, AWS, or the. Got my point, right? So,
I got your point. I got your point.
yeah.
So
So how
yes.
do we fill up those parts? Like,
Yeah. Let me answer. All right. Good question. Good question. Thank you, Tanmay. So Tanmay's question, and it's a genuine question. So the question is that since we have installed the CloudX Lab already for all of you, so you might feel that the basically most of the work is done, and therefore there are two questions here. One is we have installed already, and therefore you don't have to do anything. That's first one. Second is that there are these third party okay. There are these third-party providers like Amazon's EMR, Elastic MapReduce, as well as there are Spark can also be run on top of AWS, right? Good, good. So first, let me answer the first question. The installation as such, installation of the cluster is not too big a deal. Okay, So the documentation that I have shared with you, that one you can use to test it out. How does it look to set up the CloudX Lab kind of environment? That's first thing. Second is that when you go into an organization, the chances, the organization that I have known that work on big data, they are two kinds. One, they already have a cluster. Two, they are using AWS, right? So for the if you are joining an organization who is using their local one, then you'll be able to get CloudX Lab kind of environment already there exactly in the same way. And whatever we learn in this class, those concepts will be applicable throughout. Okay, now let's come back to two things. One is AWS EMR and other is Spark's thing on Amazon. So AWS EMR is something we have never used in this course. The the idea of AWS MR is that you write your logic of MapReduce and you give it to Amazon and Amazon will run it. So let me try to show you a couple of commands using which your existing logic, whatever we learn for the traditional Hadoop MapReduce, can also be used for AWS. Okay, so that won't be much of a problem. Now coming to the second question, second thing which you have not asked, the Spark, as we learn in the next the one which we'll go over in the next slide, the Spark can run on AWS as well. So we will cover that part during learning of Spark. When we learn Spark, at that point there will be one thing called running Spark on Amazon. So we will cover that part. Okay, so both the things we will cover as part of the course. So nothing to worry. All right. The hard parts, which are about structuring programs, deciding upon what to use when, those kind of things will stay general and stay common for all kinds of components. And we will focus a lot in building that mindset of distributed computing. All right. So don't worry about it. We have thought about this part and we have taken care of that part. All right. So most of it, because if you try to install, let's say, virtual machine, the things that people generally do, that's not really an experience. Nobody uses. Okay, so those who are not aware of, so there is something called a virtual machine of Hortonworks in Cloudera. So you can download those virtual machines and on your laptops and try Hadoop locally. But that one is one, nobody in the real-time scenarios in the industry uses a virtual machine, right? So, and second is um, the learning is incomplete. The third part is that when you use the chance of not using the virtual machine is very high. You will have the mental blocks like, hey, I'm in office, I installed the virtual machine at home computer. Second, I could not install it, it's so huge and it's not, my computer's memory is not sufficient. Okay, so for that, the the virtual machine, it does not suffice in either way. Therefore, the CloudX Labs kind of environment should work out well, but in your own time, you can try installing the Ambari as I have described but just taking a AWS cluster for maybe 10 minutes, and that should be good. It should not cost you more than say maybe $50 or $100 hardly. Okay, great, great. I hope I answered your question. Yes, Tanmay, was I able to answer your question? So the things that wherever we require the say how to run Spark on AWS, we will cover that. And MapReduce concept will remain same here as well as in AWS MapReduce. So we'll talk about those in that context. All right, great, good question. Now moving ahead, the third component that we earlier talked about is HBase. Since Dealing with files and folders is not possible in cases where we want to manipulate data in the form of records, like we want to just change one variable, we want to delete a row, update a row, and so on. In those cases, you use HBase. HBase is kind of a structured data store, humongous structured data store, which can store billions of records. All right, and billions of records and billions of columns. It can happily handle that kind of data, and that too using many computers in the network. So the total amount of traffic, the velocity that HBase can handle is really, really huge. So HBase can not only provide the storage, it can also provide you the number of transactions per second of a very large amount. So HBase is a structured store. Now, now it's a NoSQL, they call it. HBase is NoSQL. We'll talk about NoSQL HBase in details later on. Now, the third component that is there is called compute engine, like MapReduce or Spark. Spark we'll talk later, but MapReduce is something let's talk. Now, when we talk to Yarn, when we interact with Yarn, we'll have to tell a lot of details, like do this way, do that this way, and execute this piece of code here, and so on. So we kind of, have get busy with the mechanics of the work, and therefore, it's not really too productive. We are not focusing on our logic. Instead, we are focusing on which machine to execute what, right? That's where the MapReduce framework was a big innovation. So you break down your problem into something that MapReduce wants you to. You break down your problem into maps and reduces the way you break down your logic into group by and aggregation in case of an SQL. In the same way, you break down your problem into MapReduce and hand over the problem to MapReduce, and MapReduce get the work done by utilizing Yarn and HDFS. Okay, so MapReduce gets the work done for you using Yarn. The operating level fundamental operations, like the basic operations, are taken care by MapReduce for you. Okay, it basically deals with the intricacies of Yarn because working with Yarn is like too low level, therefore MapReduce. Now, Spark is a substitute for MapReduce. Almost we have moved, the industry has moved from MapReduce to Spark. And if you ask me personally, I also like Spark more than MapReduce, though I have worked with MapReduce for quite some time. Okay, the reason you will get to know very soon. One is it's faster, and other is easier to use. Spark is far more easier to use, and MapReduce takes a lot of time to get the work done. I mean, coding wise, MapReduce is slower as well as the performance wise. So most of the work is moving from MapReduce to Spark. Then there was Hive on Hadoop. In Hive, we write SQL queries, and that SQL query get converted into MapReduce logic. Because if you, not everybody can write the code. I personally don't want to write code, even though I know coding, I've been coding for like 15 years. But for many cases, like when we want to filter data, when we want to join two data sets, when we want to group the data like the way we do in Excel sheet, we don't want to really write code for that. And therefore, the engines like Hive are very useful, right? So then there is Pig Latin. Pig Latin is SQL-like interface, which was devised for distributed computing. But since Pig Latin was a newer language and Pig Latin was just too much, it has too much constraint. So Pig Latin is also kind of discarded in the industry because both the works of Pig Latin and MapReduce and all of this have been moved to Spark. Okay. Similarly, there was Mahat. Mahat was machine learning statistics library, machine learning or statistics library, meaning let's say you want to get something done most of the algorithms, most of the programs, most of the libraries, such as all kinds of libraries that have been written for Python, Java, R, all of those libraries traditionally have been written with the mindset that there is only one machine on which it will be run, right? So most of those functions have been converted into a MapReduce kind of logic, and that's what is called Mahat. Okay, so Mahat is nothing but a library of machine learning functions which can run on top of your Hadoop cluster utilizing many computers and utilizing many hard disks or humongous data. Okay, so Mahat and Pig Latin have been kind of deprecated. People are instead moving to Spark. Spark provides similar components like Hive, Pig Latin, and Mahat. Pig Latin, Mahat, and Hive. Pig and Pig Latin we call. Pig is a engine and Latin is a language. So Hive, Pig Latin, Mahat, they actually run on top of MapReduce, and therefore all three of them have been kind of replaced with Spark. All right. Next is the workflow. When you have a larger project, what you do is you create a workflow using Oozie. Okay. Now at the bottom there is something called Flume. What is Flume? Let's say in your organization you want to gather data from say 200 machines continuously. Let's say you have 200 web servers which are serving to the customer. And what you want to do is you want to continuously take the data from all machines in the organization and move the data to HDFS. And that's where Flume comes into play. Flume copies unstructured data continuously. Okay, continuously mean it runs forever. Then there is Scoop. Scoop, if your data is lying in Oracle, MySQL, Microsoft SQL, or any other database, using Scoop, you can copy the data from there to Hadoop, as in you can take the database file and put it here in the form of CSV file and so on using Scoop. Or you can just take a database table and put it inside HBase using Scoop. Although you can write your own program to do so, but Scoop is far more efficient and readily available command. So using Scoop, you can also copy back the data to the database. Let's say you're working here on humongous data. You first brought the data into HDFS, then processed it, created the results. Now you want to give it to the web server. In that case, you can use Scoop to take data which is a result of Hive or Mahat or other libraries back to the database. Okay. Okay, good question. Good question. A question from Finney. If we have 1 billion records of a customer, are these records be stored in many computers in HDFS? Yes. If you have 1 billion records and you're storing in HBase, okay, if you have 1 billion records and you're storing in HBase or HDFS or Hive, internally, it's going to be stored on many computers. Okay, but you as a user don't have to go rummage around so many computers. That's what these services do for you. They hide all the complications of what is where, what is stored how. All of the complications or complexities are hidden by these components for you. Okay, good question. Now, question from Tanma is, can you please add something about W here? Okay, good question. Good question. So when it comes to data, there are two parts. One is we process data, get the results, right? We process data, get the results. Now, looking at the results in the form of tabular is not always great, right? You can't really look at a trend in the form of tabular. Therefore, we need some kind of visualization. Imagine, imagine that, imagine that every day on your e-commerce portal, certain transactions are happening, and that transaction is being kept in the HDFS in certain format. Okay, so your e-commerce portal is running, and that data is coming via Flume into HDFS. And what you want to do is you would like to take a look at the rate at which your users are growing, right? Right, and therefore, what you would do is using these systems like Hive, MapReduce, and so on, if this data is going to be humongous, you will generate the summary of transactions. Okay, using these tools, you will generate the summary of transaction per day instead of individual transaction and so on. And once that is done, say using Hive, we do that conversion of humongous records, billions of records into a smaller insight, and then using tools like Tableau, ClickView, Power BI, or say I'll just talk about a few more. Um, say BERT, okay, or Crystal Report. You would like to visualize it. Okay, so using those tools like BERT or Tableau, you will connect to Hive server, and display the results to the end user, or you will schedule the BERT reports on the server that they get executed after querying Hive, and then you'll get an email. So Hive is not only something that converts your SQL queries into MapReduce, it also is a web server. It also has a web server that's always running and waiting for your SQL, and then it executes this and can do anything. Okay, so Hive comes with Hive server as if it's a database server. All right. So Sivani's question is, HBase also stores data? Yes. So does Hadoop HDFS. Is HBase data subset of data stored in HDFS? So instead of that way, I'll explain to you in this way. So what do we store in HDFS? Files and folders, right? In files and folders, do you think it's very convenient if you just want to, if you, let's say your data is such that you want to delete a customer, delete a particular line, update a particular line. So that kind of work cannot be done using files, right? Because when you change a file, it has to be rewritten into the disk, correct? And when we're dealing with humongous data, if we modify the file, the data will take a long, it will take a long time to rewrite the entire file. So the work which involves only appending to a file, that's great to be done using the file system. But if you want to deal with data in the form of records, right? Update this record, change this, then it's better to use HBase. And HBase internally uses HDFS in a very clever way. It creates records, and per record, it tries to create different files and so on. It does it very cleverly. So HBase internally, it's like it's like saying that this is MySQL or Microsoft SQL, in which you update record, delete record, insert record, and this HDFS file system is where the Microsoft SQL also keeps the data files, right? MySQL, Microsoft SQL, they also keep the data files in your local file system. Similarly, HBase provides you a way to manipulate records, but internally it keeps the data files inside HDFS. Make sense to you? Okay. A easier way to visualize is that you can see the folders, files, you can create new folder, new file, and so on, right? This is the HDFS. while the H base looks like this. Okay, so we can say new table, and we can define a table, define some column family, and okay. So this way we can deal with the table. Okay. Okay, something is wrong. We'll take a look at it later. Okay, good. A question from Yograni is, Finny, is that if we do shopping at Amazon online website, is it dealing with Hive and then to HDFS for shopping recommendation at the same time? No, I'll tell you. It's a very good point. Very good point, Finny. Finny's point is that uh, dealing with this Hive and HDFS, is it happening in real time in case of Amazon? The answer is no. Okay, so the way it happens is it's a very important flow, and you must take a look at few more blog posts. We will talk about those blog posts later. All right, so I'll draw it here. Okay, so the way it happens is the workflow. Okay, I think we should take a break. All right, let's just take a break, and I will start from the question asked by Finny. Okay, Finny, you can ask your question publicly. These are very nice questions. Okay, all right. So break for 10 minutes and back by 10:03 p.m. IST. Please post the time in your own time zone. All right, that'll be easier for others. So somebody can post the time zone other than IST. Okay, that'll be easier. All right. All right. So should we start? Great. Great. Okay. So coming back to the question of Finney, we do shopping on Amazon online website. Is it dealing with Hive and then HDFS for shopping recommendation at the same time? So two things. One, Amazon uses its own services and they are built on top of similar infrastructure like HBase and the HDFS. They have a similar architecture inside. and But it doesn't happen in the real time that way. The way it happens is we basically take the old user behavior, okay, older data, the logs and behavior, okay, and what we do is we take this data that there will be a lot of files, the website log and everything. What we would do there is every night or so, okay, every night or so, we would produce the recommendations, okay, generate recommendations, okay, and the way recommendations are generally maintained is okay, they are maintained either in the form of user per user, okay, either per user, okay, like these recommendations are for Sandeep Giri, and then there are recommendations which are per product, okay, which are called people people who bought this also bought that. That's per product, okay. And sometimes we do not have this is great for the people where the user is not signed in, or this is great for the case where user is not signed in or user has not bought anything so far. We don't have a history of the user. Okay, in that case, per product, as in people who bought this also bought that, or those kind of information are very useful. And sometimes it's the recommendations are also based on we call that demography. Say a user has come to your website, the user never visited anything, and we don't know which product is he watching. In that case, we pre-prepare the per demography recommendations. So we pre-prepare per user, per product, and per demography recommendations and all kinds of recommendations. We prepare every night or so, and then keep them ready to be served. Because when the user is coming on the website, the user should not wait every now and then. So once you have generated the recommendations, these ones, we transfer these transfer these to the web server. Okay, we transfer these to web server, the usual web server, maybe, or database server. Okay, using tool like Scoop. Make sense to you, Finny? Was able to answer your question? It depends how big is this data. If this data takes more than 24 hours to do, we run it maybe in 2 days at a time, and so on. Okay. So it depends on how much time it takes actually. Sometimes what we do is we break it down into three parts. Per user, it runs every day, while per product, it runs in 3 days. Per demography, also it runs later. Okay, based on how much time it's taking. I hope I was able to answer your question. Very good questions. Keep the questions coming. We all learn this way. Question from Yogurani, can HBase be replaced with MongoDB like that? Yes, MongoDB is also a similar replacement, a similar database like HBase, just that HBase is great for data in tabular form, while MongoDB is good for complex objects like huge objects, like a web page having many properties. For those kind of scenarios, MongoDB is good. Okay. Also, MongoDB, I don't think it runs so easily on Hadoop, but HBase runs on top of Hadoop. So if you have Hadoop already, you don't need to install anything else. You already have out of the box HBase installed. A question from Tanmay: what kind of software systems are we building here? Batch processing or very good point. Okay, let me just make a note here. Fine. Okay, so what kind of system are we working with here? We basically will deal with like four kind of things. One is existing softwares, okay, such as like how to use HDFS and other tools, while the batch processing is what is done by Spark and Hadoop both. Okay, batch processing is done using Hadoop and Spark that we will deal in the details. And online transaction processing is something which we would not be able to do using these tools so easily, because most of the transaction processing is done by the way of NoSQLs and using the big data tools, because big data tools run in the are used in the case of humongous data. Therefore, OLTP, because the big data tools are run on top of humongous data, therefore, big data tools do suffer from inconsistencies from time to time. Okay, we'll talk about this particular part, why the transaction processing, the online transaction processing is not a great, none of the big data solutions are great for OLTP. Okay, although to some extent you can emulate this with HBase, but not much. Then the data warehouse and OLAP is something we will learn. Okay, we will also learn something called stream processing as part of this course. Okay, so there are a bunch of softwares. Most of the computing engine, whether MapReduce, Hive, Piglatin, Spark, all of those are in batch processing. They do provide the functionality to do the stream processing, okay, but most of them are for batch processing. The OLTP is something that none of the tools are basically capable of in this. We will talk about these in more details, okay, because the definitions wouldn't make much sense. As we go more details and we do more hands-on, you will get the clear picture. All right. Thank you, Bhuvan, for answering the question. So online transaction processing is something that these are not suitable for. All right, so the next component that we talk about is Spark. Spark is basically Hadoop MapReduce's replacement. It's really fast, and it can run everywhere. It can run on EC2, it can run on Yarn, it could run on Mesos and standalone. We will not be able to you know work with Amazon EC2 right away, but we will give you an example of how to run your Spark application here, here, or here, as well as standalone. Okay. Spark can read data from all these places. We will be reading data from here, here, and here in this course. Tachyon and Cassandra we don't have access to, but can be done easily. But we will be teaching you this part. Okay. And with respect to libraries, because Spark Core provides you the basic infra for distributing the computing, but most of the practical applications are either done using SQL or kind of Spark, kind of real-time processing of data, or the complex machine learning applications, or graph processing. These kind of applications are very well done using these provided libraries. Also, we can access Spark using any of these languages, and we will be doing one example of each. That's it. So that's it about the basics of it. So the Linux part, I'm leaving it to you, or you want me to give overview? But I would strongly recommend that go through the given Linux environment. All right, I'll just give you these 2 minutes overview of Linux. All right, so Linux is everywhere on all the things. In the phone, the one that you call Android, it's actually Linux. Then in cars, in fridges, and the watches. Okay, so most of the systems that you see are built on top of Linux with respect to operating system. Android is nothing but a modified version of Linux. So Linux operating system or any operating system has two parts. One is called programs, another is called kernel, and third one is called shell. So shell is also a program that interacts, that sits between the user and the kernel. Okay, so you can connect to the Linux console either using web console, using SSH, or so the way we just showed you that you can connect to the web console using here. If you are from say Unix background, you can simply use SSH here. You can say SSH your login ID at whatever is your host name. In my case, it's E, right? And you can connect there. All right. If you are from Windows, what you can do is you can use PuTTY. Okay. For you, when you do SSH or PuTTY, it will prompt you for password. And when you type password, it won't display anything. So be aware that it's working fine. It's just that it's not displaying the password. Okay. So we are able to log in from the local terminal. This is my Mac's terminal. And if you are on Windows, you can try logging in directly using PuTTY, but that's not much required. Okay. Okay. So all right. I don't know why it's so slow. this guy. Okay, now coming back to it, in Linux also the there is a file system. Okay, the file system is of the hierarchical structure. At the top level there is slash, then there is tmp home etc. Okay, I'll show you this. We can't go up. Okay, let me go back here. I'll show you. Okay, actually, yeah. So a very quick overview. So in Linux, there are three things. One is program. Anything is a program. Every command is a program. And then there is kernel and there is a shell. Okay. So the heart of the Linux is also a file system. File system as in files and folders. Okay. So in Unix or Linux, everything is a file. A command is a file, a device is a file, and so on. Okay, the file system, the whole file system, starts at slash. The whole file system has a single top level directory called slash. Under slash there is tmp home etc. Okay, and there are many other similar folders. Tmp is for keeping the temporary data. Home is where everyone's home directory is kept. Okay, etc is the place where configuration is kept, and there are var where is for keeping the data from the dynamic data, such as process IDs of various applications, the data that continuously changes. Okay, so in Linux, everything, to my surprise for the first time, everything is a file. Okay, when you say ls command, it's a file stored in the file system. Okay, so this is the way we connect to the Linux console. And let's go through the commands quickly. I'll just take you through the commands quickly. Okay, but it doesn't mean that you would skip this Linux tutorial. Okay, this Linux tutorial is mandatory and you must finish it. Okay, the progress is, you can attempt many times all these questions. Okay, we have the record of the entire, the all the attempts. Okay, now coming back to the Linux console. Okay, so this is our Linux prompt. How many of you are comfortable with Linux prompt? Please raise your hand or type. Manoj is comfortable. Yes, only Manoj is comfortable. Tanma is also comfortable with Linux. Okay, who else? Arun is also good. Good. Okay. All right. All right. No worries. Shivani has never worked. What about others? Are you comfortable with Linux or Unix? Or have I put you to the sleep? I see. I see. So the one which we are using on the server is actually CentOS. CentOS is same as Red Hat Fedora. So you should not have any problem at all. Good, George. Fedora is nothing but a flavor of Linux. Great, great. So let's get started with this part. All right. So when you log in into console here, this place is called shell. Okay. This place is called shell. You can press enter here. So this one is waiting for your commands. And the way you type command is this way. And every command can take arguments. Okay. Every command can take arguments. And here we are not providing any argument to it. So here ls minus l, this is the argument, and ls is the command. And what does ls do? Ls displays list of the files. Okay, ls displays the list of the files. All right, and ls minus a l displays the list of files in the list format, as in this way, longer list format. Okay, now it is displaying the list of files from which folder. And that's where the idea of current folder comes into play. When we are on the shell, we have something called a current folder. And how do you find out current folder? Or we call it present working directory, PWD. So we are right now in this. For you, it'll be your home directory, where that one is your default. This is my default working directory. For you, it'll be slash home slash something. So when we are here, it's waiting for command, and it has set our home directory correct accordingly. Okay. Now to change the directory, we can use cd. Okay, cd is for changing directory. There are two ways of changing directory. One is either we call directly like slash home. So we'll go to the slash home. Okay, so now our working directory is this. And when we say ls here, it is showing us all the list of username, because every username is given a directory. Therefore, this is showing us the the username. Okay, so now when you want to go to home directory, either we can say cd, or we can say tilde. Tilde means your home directory. Tilde is a shortcut to say this. Okay, we could also go to the top level directory by saying cd slash, and if you say pwd, it's slash. If you say ls, it shows all the directories at the top level. Okay, I hope everybody is comfortable so far. So there is a concept called present working directory. Present working directory is the directory from which ls shows the list of files. All right. The first argument, if we are providing say dash help for ls, it shows us, let's say dash dash help, it shows us all the information about the command. Or we could use man ls. Man is for manual, to understand the intricacies of every command. Okay, say I say man pwd, man pwd. So it shows us the commands here. Good. All right. So if we want to take a look at the text file, we can take a look at it using either cat, like we have cat a.txt. A.txt is this file. Okay. And if you want to edit a file, we can use one add text editor called Nano, or we could use a text editor using the VI or something else. Okay. Any questions? Yes, Arun, you have a question? You have raised your hand. Okay, good, good. All right, so I think he raised a hand for saying that he's okay with Linux. Good. So this was a very quick short tutorial on the Linux, how to interact with various things. Rest of it, you must go through this one. Okay, this is good enough. It's actually not very big. It's really small. Just go through it very quickly. Okay, in your own time. Now, all right, rest we can take care later. All right, great. Is everybody okay so far? Arun, Bhuvan, Fini, George, Manoj, Rex, Sivani, Tanmoy, Yograni. All right. Should we start with Zookeeper? Great. Wonderful. All right. So Zookeeper is the core component which is not mentioned in the architecture in the diagram, the one which is discussed. The Zookeeper is a very important component of the entire ecosystem. Though nobody tends to cover Zookeeper in their courses, but we realize that if somebody needs to really design the systems, they need to be aware of Zookeeper. Zookeeper is used by HBase, HDFS, Yarn, Kafka. Kafka is another tool called for queuing, and many other third-party systems, including Cassandra, and everybody uses Zookeeper. So Zookeeper is the heart of it. All right. The other reason why we want to cover Zookeeper is a great example of distributed computing. Okay. Zookeeper is a great example of distributed computing, and this course is about distributed computing. Okay. So if we miss out on Zookeeper, we will be missing out on a very important architecture. And that's why we want to cover Zookeeper. All right. Great. So everybody is ready. All right. So before we jump into Zookeeper, let's clear up couple of ideas. Okay, couple of ideas. All right. Sorry for being mute. Okay. So before we jump in, my question to all of you is: have you heard about the term called race condition? How many of you have heard about term called race condition? If yes, then what do you understand by race condition? All right. Okay. So what is race condition? Now I'll give you a very better example here. I'll give you a better example. Now imagine there is a bank account, okay, and program A or program B, or you can say person A and person B, both are trying to withdraw or deposit $1 into this bank. Two persons concurrently trying to deposit $1 into this bank account at the same time. So if there are two people trying to deposit $1 each, what should be the outcome? If the bank balance as of now is 17, it should be 17 plus 2, right? It should become 19. But if your program is written in this way, I'll show you. If your program is written in this way, get So current value equals get bank balance, okay, and then you're saying not correct, it's current, okay, current value equals current value plus 1. Okay, I hope this is just a pseudocode I'm writing. So first you're getting the bank balance, increasing it, and then we are saying save bank balance, right? And we are saying yes. Now this logic seems to be right, okay, or we can say deposit amount, okay. Let's say I'm just writing a function called deposit amount is this, and this is what it does. So this is our function called deposit. It takes this amount and it takes the current value, adds the amount to the current value, and done this, right? This looks really nice code and looks very clean, and none of us would ever blame this piece of code, right? Looks really nice. Do you find it very uneasy, or this is good enough for you? So you are writing a function called deposit. You take the amount and you fetch the current bank balance, increase this, and then update this, right? Is everybody okay or with this? Please interact. Let's say you're writing a function called deposit into the bank account, and what we do is we take the amount, add to this, and that's it, right? Now it looks really simple code, right? It looks really simple code, no big deal. Everybody writes this way. But truth is, this piece of code could actually corrupt your bank account. Okay, imagine that two persons, A and B, both are depositing the amount at the same millisecond, same spot, same nanosecond. They are trying to do it, and and let's say both of them fetch the current value, the first statement, both of them has done that at the same time, right? They fetched 17 here, right? The value at this point of current value is 17, and then it increases the amount. Both of them increase it by 1, okay? And then both of them save it. So let's say your database is really safe, and what it does is, while saving, it saves the last one last, and so on. It basically queues the incoming transactions. Okay, so at the end of it, both of these, person A and person B, the programs of these in the back end saved 18. Okay, they saved 18. Does it make sense to you? So even though the program was perfect, there was no bug in it, but there is a bug in the whole system. This is called race conditions. Two programs or two instances of the same program competing with the resource. Competing two programs or two instances of the same program competing with the resource. Competing for the resource, not with the resource, competing with each other for the resource, and thus corrupting the data because of these kind of inconsistencies. Okay, so does everybody understand what is race condition? This whole scenario, this kind of circumstance is called race condition. Arun, Bhuvan, Fini, George, Manoj, Shahrukh, Rex, Shivani, Tanmoy, and your granny. You want me to repeat? Anybody? Question from Manoj is, this has to be handled by the given database system to avoid it. Okay, so it is the responsibility by both of both the people who are writing the program as well as the system which is providing you this. Okay, if system is not providing you a way to make concurrency, then you will have to design your own. Okay, so this is where the locks come into play, where we want to create locks, create lock as in we want to create something called a monitor, semaphores, locks, and so on to avoid such kind of bugs in the system. Okay, and you will be surprised to know that 90% of the programs would have a race condition. It is very much possible to have race condition in most of the programs. And specifically, the programs like Unix shell scripts are very much prone to the race conditions. And race conditions are exploited for security, can be exploited for all kinds of situations. So when various kinds of security bugs are actually race conditions. All right. Now, the second question to you, all of you, is what is a deadlock? These terms we will be using as we go forth. That's why I want these terms to be very, very clear. Because race condition and deadlock seems to be confusing terms mostly. So I want to be very, very clear. So question to all of you is, what do you mean by a deadlock? That's right, when two or more transactions or processes are waiting for each other and no one can proceed. Yes, when there is a cyclic dependency that I will wait for you and you say that I'll wait for you and we both are waiting for each other infinitely. That's called a deadlock. Okay, this might sound very hypothetical situation, but it's again a very common one. Yes, that's right, Shivani. So yes, even though these things look like very hypothetical while we are studying in the book, but truth is that these things are very, very common. And in my career, I have seen deadlock multiple times, and I was surprised to notice that even though the code at times looked really clean, but there was a deadlock which we did not see. Okay, and when these kind of errors occur in production, they lead to corruption. uh, this deadlock leads to forever, the system could wait for forever, and the system could become non-responsive completely, and so on, right? And this deadlock is very common in the high traffic areas, right? You can see that first car is waiting for second, second is waiting for this one is waiting for this, and this is a deadlock. So here is the diagram that shows it. Now, we talked about two things. One is deadlock and race condition. I hope you are all clear now. Point from Manoj. Deadlock happens due to bad design of an application. It is never database's design problem in general. Good point. Very good point. So deadlock does. So most of the databases are designed in a way to avoid deadlocks. Generally, such kind of errors do occur because of the individual program's problems, and because databases have been designed to provide you transactions. So database provides this construct to wait for a transaction to complete, and therefore the feature called transaction, if not used properly, could lead to, it could be one of the reasons to be, for the deadlock. Okay, we'll talk about the acid properties of the database later. Okay, now question is about coordination. Let me ask you a very simple problem. Okay, so how would email processors avoid reading same emails? Okay, that's the question. Imagine that there is an inbox. Okay, imagine that there is an inbox. That inbox is email inbox. It contains lots of emails, and these emails are coming in continuously, right? And you want to index these emails. You want to provide a great search on top of these emails, and you want to process these. Okay, you want to process these emails as and when these emails are coming, and you realize that the work of processing email needs to be needs to be is a very heavyweight work. As in, when we are processing emails, the time it takes for processing each email may be few seconds, and there are just too many emails. So we might require many email processors running on many computers, right? So here's a design problem to all of you. The design problem is, and these design problems will occur to you in your career very often. Okay, so this is from my own experience. So we were doing the email processing for two-way email integration with the system. So there were multiple email processors, same program running on first machine, second machine, third machine, and all we were trying to do is we were trying to process these emails, right? Now there are two problems here. One, email processors 1, 2, and 3, all three will compete for same set of emails, will compete for same set of emails. Second, processor 2 and processor 1 might end up waiting for each other, might end up waiting for both to be to you know, there could be a deadlock if we try to coordinate. Now question to you is, how would these processors, these email processors would coordinate with each other so that no two email processors try to process the same email, as well as no two email processors skip, none of these email processors skip any email. Okay, so question is, how would you design such system? What would you do in these cases that such that these email processors do not skip any email, as well as do not process same email twice? Here is few more information for you. The inbox is read only, meaning you cannot you may mark email as, you know, read, unread. That's all you can do. Other than that, you can't do anything about it. You can't delete an email. You can only mark it read or unread. Okay, read or unread. So that's the only thing you can do, but you cannot delete or do anything else. Second piece of information for you is, each email has got a unique identifier. So how would you design such system such that you can process humongous emails per second using many machines without processing same email twice, as well as without skipping any email? Yes? What would you do? Manoj's question point is that we can do queuing. Different emails are sent to different processors. This can be done in time ordered manner to different machines. Okay, good. So Manoj and Tanmay, both of you are assuming that this inbox will be read by something called, let's say, a judge, right? And that judge will delegate the work to these email processor 1, 2, and 3, correct? Okay. While Manoj is saying that we can round robin it based on certain fashion in the way, in whatever time the emails are coming in, we can keep on in a round robin way. While Tanma is suggesting that we could, based on the email ID, ID of the email, we could do the partitioning. Okay, both are very similar approaches. Okay, and additionally, as per Manoj, we can divide emails at sub-second level and shard partition the emails. Okay, so now a question to you, Manoj, is that what if this master or this judge that you're talking about dies, right? Even though, let's say we have four machines, first machine is behaving like a judge and which is dividing emails amongst them, the master is, then we will need a standby. That's right. Also, what has been done and what is being done is also need to be kept somewhere, correct? Yes. And that standby you will have to start by yourself, or how will standby and this machine coordinate? Any other suggestions? All right. So Finney's point is that could you give a scenario of use case of big data volume as needed of business functions in reality other than storage, including how much duration takes to load the data like 20 million records in daily or hourly basis? Okay. Okay. So this one I can take it next time. Okay. So I think we can start with that question in the next session. All right. Or you can maybe leave it on the forum. Maybe I would love to see other people's feedback as well. Okay. Any other suggestions for the coordination between these email processors? One is an approach that we create something called a partitioner, secondary, somebody who will delegate the work between these three processors. Any other suggestions? A suggestion from Shivani is that we can use read unread indicator. Good point. But imagine this, let's say there is an email processor one, which is just reading email one. So we need a third state as well. Read, read, unread, and reading. Reading. Third state called reading, because Let's say email processor 1 has started reading it and it marked as read. What will happen is, what will happen is email processor 2 will skip it. But if email processor 1 dies while processing email 1, then that email 1 is marked as read and then it will never be processed again. Correct? And if email processor 1, let's say we design it such that only after email processor 1 finishes processing of an email, only then it will mark it as read, then what will happen is, if this email processor 1 is processing it and it has not marked it as read, email processor 2 will also start processing it. Correct? Though your logic is correct, it can be done in the same way. Okay, very good answers, Manoj and Tanmay. Any other suggestions? And Shivani, any other suggestions? A question from a point from Manoj. Even without the third party, say, let's say processor 1 should process emails coming at seconds 0, 3, 6, and 9, and so on. And second processor should process coming from this and so on. My question to you is, basically you are saying that we'll do it round robin, correct? How would the fault tolerance be maintained? In case one of them goes down, what happens? Will the other person be take over? Will it cause gaps? Also, when we are in the distributed computing, we'll be putting the same code in all the three places, right? Same code. Very good answers. Very good answers. And any other answer, please? Okay. So Manoj's suggestion is that we can divide the work and then we can have observer or a central server. Good. Good. All right. So I'll suggest you how did we solve the problem. Basically, the key insight was that we can have email ID somewhere. So what we did was we maintained in another database at a central place saying whatever emails are under process, we maintained a central storage. Okay, we maintained a central storage, and the logic was that processor 1 or every processor will go to the inbox, go to the inbox, go to the inbox, and go to the inbox, and what it will do is find out all the emails that are go to the inbox and read the emails which are unread, and then go to the central storage, and basically it will keep on trying to get the lock, okay, on that particular email ID. That's what it will do. Okay, it'll basically take the unread email, put it in a central storage, the email IDs, and put it in central storage, and then the processors will keep on trying to get the lock on those records. So using the database's locking mechanism, we were able to build this kind of processing. Okay. So you get this idea? So using the central storage, another central storage, we were able to make processors coordinate. Did it make sense to you? You want me to describe it more? All right. Please keep in mind that the course is very hands-on, and we are going to go into the design of things. All right. And the idea is that only after you understand how each component behave, you will be able to design a big data solution. Okay. That does not mean that it'll be too hard. Okay. It does not mean that these sessions are going to be too hard. Just participate and ask questions whenever you get the question. All right. So Tanmay, did I make sense to you? If you maintain a central storage, and then we, every email processor's duty is that whichever is unread will go and put it in the central storage. If it can acquire the lock, it can pick it. Okay, so there are 2 points from Manoj and Bhuvan. That's what I wanted to say by queuing, correct? Queue status will be maintained on a third server so that it can be done as you mentioned. Correct, correct. So that queue was the key in your design. All right. Question from Bhuvan, a small scenario. If processor 1 starts reading email 1 and fails after 5 minutes, would processor 2 starts again from the beginning to identify email? Yes. And yes, George, I suppose each processor is independent from each other. Correct. Okay, so we'll continue our discussion from here tomorrow. We are going to understand the Zookeeper's design, not only because Zookeeper is very much required, but because many other systems, including MongoDB and others, have been designed in a similar way as Zookeeper. All right. So I look forward to see you tomorrow, and we will go into more details into Zookeeper and then Yarn. All right. So please keep working together on this. In the meantime, do take a look at the self-paced course. I have whatever I am speaking right now. I have also recorded it, and there are exercises that side. There are exercises in the Zookeeper, so that you can whatever we are learning, you can retain it. Okay. So if you go here, I will. If you go here in the Zookeeper section here. So whatever we have discussed, it's already recorded, and there are questions. So please attend to these questions. They will help you recollect and retain what we have discussed today. All right. I look forward to see you all tomorrow. Bye-bye. Have a good day. Bye, Arun, Bhuvan, Finny, George, Manoj, Shahrukh, Rex, Shivani, Tanmay, Yograni. Please provide the feedback. We'll be sending you the link after the session. Okay. I look forward to see you tomorrow. Bye-bye.